Okay, so over the weekend I was reading an article. I can't now find it, of course, but I was reading an article about how we figure out where there are black holes. And in the article, they had this nice little applet, right? Like some little GIF that somebody had made with little blobs and a black dot in the middle, and the little blobs orbiting this black dot, right? And so I thought to myself, that looks a hell of a lot like a processing program. I should be able to write that in processing so that I could play with initial conditions and gravity constants and see what happens, right? I was kind of thinking I might pass this along to Anka because, physics people love this kind of shit. So I spent a minute trying to do it, and I ended up fighting with p-vectors. So this is kind of a roundabout way to introduce p-vectors a little bit. But I want to show off basically the finished product here first. So first things first, my code is not commented because I was having such a bitch of a time getting this to work. But I think I finally got it working. So let me run through basically what I've got here. So up here I have some constants. V-bound is just the starting velocities of everything. The number of bodies is the number of objects that are going to show up on the screen. The float k is basically a gravitational constant. I just kind of was fiddling with it. And then I've got setup that's making a window, and what's this business about? Oh, sorry, I missed one. What's this thing do? Yeah, it creates an array called bodies made out of instances of the body class, right? You guys see that? So there's someplace in this, there's an object or a class called body, right? And I'm going to make a bunch of objects out of that thing and then pile them into an array, right? So here I've got my setup, I've got my size, I've got my, what is this business doing?
For each body in the array, it's making a randomly sized square.
Close. So square here is a method that's defined down at the bottom. So square is a method that takes a float and squares it and returns it. You guys with me on that? I just couldn't remember what the name was for this thing in processing, and it was faster for me to write this than it was for me to go look on Google and figure out what the name was. Yeah, I'm sure it's SQ or math.sq or cmath.sq or some damn thing. But
why figure out whether I need to go to math first?
Yeah, totally. And I didn't really want to deal with maybe having to import a package or whatever. It was just dumb, so I just made it. I did the same thing with cubing because I was using that for a minute. I don't think cube actually gets implemented anywhere anymore. Okay, so this is making a bunch of bodies with some pass to the bodies, right? Each one takes some kind of number that it does something with. And that number's a square of a number between 0 and 10. And then I've got a frame rate, cool. And then in here and I didn't need this push matrix anymore, so we're doing a draw, right? And we're setting the middle of the screen to 0, 0, right? That's what the translate does. And then I'm setting the background to white. And then here I'm looping through all the bodies, right? And the first thing I'm going to do is I'm going to get the acceleration for each body. And then I'm going to update the body. And then I'm going to draw it. And then I'm going to draw its path. And I'm not going to go into the math of how each of these things work, but you can just play along with me, right? We're going to go through the bodies. We're going to see how much they should accelerate. We're going to accelerate them to where they ought to be, update their velocity and their position. Then we're going to display them. Then we're going to draw some kind of path behind them. And then this is the thing that I was going to, the reason that I'm showcasing this, partially at least, is here I have a little for loop, right? Oh, and my for loop should have brackety brackets. Kind of surprised that didn't jack everything up. It's because it's at the end of the block. Okay, so I've got for... Ooh, I'm looping through the bodies again, right? You guys see that? And we're saying, well, they should at least be different bodies, right? And then what am I running here? Yeah, this part here is saying run the collide method on the first body you were looking at, right? So like the one you ran through all the acceleration, update, display, and draw path, right? Like all that stuff, you're checking did it collide with this other body? With each of the other bodies, exactly. So if there was only one, like if there were only two, right? This would be just did the two things collide? In this, it's got to be did this one collide with any of the others? So this like goes around the room basically and says, did I collide with you? 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 And that's kind of how this goes. That gets to be a lot of checks, right? For loop in a for loop's a lot of checking. Okay, and then bodies have stuff, right? So like this is all the stuff that a body has. It's got a mass and a radius and a location x coordinate, a location y coordinate, a velocity x coordinate, a velocity y, an acceleration x, and an acceleration y. There's a whole bunch of physics for why you would need all this shit that I don't really want to go into. Cool. But it's got a bunch of attributes. And then it's got an what is this? Close, yeah, that's a float array, right? An array made out of floats called PathX that has initially nothing. So, like, that's going to be what I use to keep track of where the path is. Right? Like, this is going to be a list of where this object has been. Really, that's going to be a list of where the x-coordinate of this object has been. And then the path y is going to be a list of where the y-coordinate has been. And then it's got some kind of a color, and then it's got some kind of Boolean that's just like, do you draw the path for this or not? Right? And then here I've got the way I make one. So I make an object. It's got like a mass that's passed to it. So that's what that square of a number between 0 and 10 was. Right? So it's getting some kind of mass. And then it's getting a radius that's the square root of its mass, because reasons. Don't worry about it. And then a random color. I stole that from Growballs, by the way. And then a random x location, a random y location. Set the x and the y acceleration to 0 to begin with. Some velocities. Right? So some random x velocity, some random y velocity. And then start path x and path y at lx and ly. So I declared temp mass right here, and vbound is a global. So vbound isn't a property of each instance of the class. It's a global variable that I'm using so that I don't have to replace these guys if I want to change, like, how fast is shit allowed to start in my little universe. And then I've got a display method, and basically the display method just draws a circle, right? And then the update method says take the velocity and change the velocity by the acceleration. And so just add the acceleration to the velocity. Then the location says take the old location and add the velocity. And then the path just gets updated. Right? Every time you change the location, the path should be updated. So that's what my update method does. And then my draw path method has a stroke that's the body color, right? So the colors match. and then it just draws a bunch of lines between the elements of the path X and path Y arrays. And then the acceleration is a whole shitload of math that I really don't want to get into, but trust me, this is vaguely appropriate math for doing gravity. Probably. It should be noted that I'm not a physicist. I vaguely remember how gravity works, and so I made some educated guesses about equations. And then the body collide was a thing I wanted to highlight. But let me basically say this about it. What it does is it checks whether one of the objects is bigger than the other, and then it combines them. And then it zeroes out everything about the one that was smaller. You guys cool with that? And then there's the, so there's if one's bigger than the other, and the other one is, So you need both comparisons, basically.
Is other a method?
Oh, yeah, so should be noted that what I passed, the collide method, was a body called other. Right? I passed the collide method something. What I passed the collide method way up top was, right, I did body.collide, and I told it, take this other body that you're comparing it to, right? And then down in the method itself, I called that thing other, because I didn't know which one it was going to be, right? And I didn't want to hard code it, because I'd be like screwing with one of the other bodies, but not knowing which one it was. You guys see that? So I made some dummy variable, right? That's like the temp mass that I used earlier. This is like temp body. And the other was just how I was thinking. So if I run this, I get a whole bunch of little dots. And sometimes they collide. And sometimes they kind of bend each other around. And we're going to have to run this a couple times to get something interesting to happen. It's kind of like a game. Yeah, it's a little bit like Growballs, actually. I think if we wait a second here, this one will start to orbit. Maybe. The only time they disappear is when they actually collide. Come on. Did you escape, you little bastard?
Yeah, he's straight now.
Yeah, I think he escaped. Yeah, we could. The things that are cool happen pretty quickly when they do happen, so... That was cool. That little guy got slingshotted all the way around. That one's coming back from some damn place, right? Like, he got slingshotted around outside the screen. Let's see, what did I change? So... Yeah, so we could make gravity bigger, right, by increasing K, or by increasing the possibilities of our masses. So I'm going to change both those things, and we'll see what happens. Come on. Somebody orbit something. There we go. Damn it.
There's still one more coming.
All right.
But, yeah, but it was off screen.
So obviously there are improvements that I need to make to this piece of code, right? Like what I really want is like a zoom in, zoom out button here. So I could like zoom out a bit to see if anything interesting is happening off screen. Yeah, so what if we lower initial velocities a little bit? There we go. That's going to be an orbit, maybe.
Maybe.
Come on.
Kind of have two orbits.
The car is slow moving, so it might get messed up.
No, it'll be okay. He's coming back here. Where did that thing come from? Oh, no! Well, everything collided. Let's see. So, another cool thing we can do is crank the number of bodies.
Oh, do not.
I think we need a bigger window for that.
That is how black holes are made.
Let's see. And I think if I make this a cube, we'll get a bigger variety of... Oh, God. Let's see. So we need to turn this down if we're gonna cube things.
Also, you got 200 bodies.
It'll be something interesting's bound to happen. So it's actually kind of.
Oh, you got one.
Oh, hey.
Oh, and that's what orbit looks like.
Pretty stable. Very stable.
Yeah, that one actually looks really nice. I have had orbital. So in fiddling with this, obviously, as soon as I wrote this, I sat here and frickin' dorked with just trying it over and over and over again, like a million times, right? And in that process, I observed at least one instance of a nice orbit like this degenerating at, I think it took 35 turns. Like, it did 35 complete orbits before it got sucked in. So it just had the tiniest little velocity towards the inside. It was cool. Yeah, so we have one little object and another little object, each orbiting separately, which is rad. That's exactly what I was hoping to get.
One's Mars.
Yeah, or given the relative sizes here, this is maybe more like what Mars looks like. It does have two extremely tiny little moons that are out at different distances from one another.
One's going around many times, and then the other one goes around slowly. So it's like the length of days kind of thing.
Yeah, so the orbital period, right, the amount of time it takes each of these two little moons to circle this thing is different, right? Which is really rad. That's super cool. So,
I think we lost the outer one.
Oh, no.
She's slow.
yeah, he's just really slow. His orbital period is something like 3 or 4 times that of the little one. So this is cool, right? So I was super psyched to get this thing working, but I tried it with p-vectors, and I just had a hell of a time with it. So I'm going to try to write something else with p-vectors for you guys, just to, like, illustrate some of the weirdness with p-vectors. Cool? Questions on this? Questions on why this thing is working the way it is? Can we just leave it running?
You know, you could put it on.
Do you guys want this code?
I mean, I do.
Okay,
I
so-
like this sort of stuff.
I will make this code available. I would like, yeah, if someone wants to earn a solid pat on the back, if you add a button to export the initial conditions and a button to import initial conditions, or do it on enter press or something, that would be freaking awesome. Yeah, like this thing,
To change the variables before it starts.
Yeah.
this thing had a whole bunch of, like,
Random.
yeah, there were a whole bunch of randoms that were made, right, for each body. If we recorded those somewhere, then we could, like, you could be like, hey, I found a really cool set of initial conditions. It's got a thing that orbits another thing with another thing orbiting that, right? Like a sun, moon, and Earth system would be super rad to see in here. And it's totally possible, but the probabilities of observing it are really low. Right? Basically because my system here doesn't have enough time to evolve. And you'll notice actually that it's starting to get a little choppy. Why is it starting to get a little choppy?
It's still technically running a bunch of other things.
And it's recording all of those rotations.
Yeah, every single one of these every single one of these turns, right, is making a whole mess of array appends, right? And every time the append command runs on an array and an element, right, it takes that whole array and copies the whole thing down and then adds one element to the end. And so I have that happening at least 3 times in here still. The other ones are all getting copied too, they're just full of zeros. Right, so if you wanted to do a better job of this, you would like turn the appending off, like this part here, where the path gets modified. You'd turn that off if you're not drawing it anymore. Right, like if that thing's gone, you don't need to update it. You guys see that? So really up here maybe, I could put if mass isn't 0, do all this stuff. Right? And if mass is 0, just don't do anything. That would be a great fix that would save a bunch of computation time. As it is, this laptop has like 16 gigs of RAM, so I'm kind of okay with it. But cool. Questions, Steele? Yeah, that's really rad. A zoom out button would be freaking killer too. Just saying. I was psyched. It took me a long time because p-vectors are a pain in the